Okay, let's look closer at the vertex. What are the coordinates of the vertex for any quadratic function written in vertex form? And there it is written there for you. So here it is, vertex form. So if we look at our two examples, here's that vertex happening at the point 3 and -1. And then if we look at our second quadratic function, here's our point here happening at -1 and -2. Are you noticing anything compared to, if we look at the equation and if you look at the point value of that vertex, is there anything you can see? Maybe you notice that x value, whatever it may be, is that p-value inside the graph. Remember how we talked about how whatever that p-value is would be the opposite? So just like here, if it was a +3 in that equation, it's a -3. Or my second example where we have the x value is -1 of the vertex, inside the equation it's written as +1. Now that y value is -1, which is the same as that constant. And the y value of the second example is -2, the same of that constant. So what would the coordinates be of the vertex for any quadratic function? Well, your x value, whatever your p is, you gotta write the opposite, and whatever your q value is for your y point. So here is the graph to the right. In my equation, we have the p-value as -4, so it would have to be written as the opposite, so 4. And the q value is 2, which would be my y value. So let's check to see if that's the same on our graph. Here's the vertex, and it is happening at the point 4 and 2. So let's look at our next example. Here is the p-value, it's -3. We have to write the opposite, so +3. And the y value is -1. Let's compare on our graph, and sure enough, that vertex is on the point 3 and -1. So once again, whatever that p-value is, we have to do the opposite, and that'll be our x. And whatever the q value is our y value. Let's look at the axis of symmetry. So the dotted lines are the axis of symmetries for each of the following quadratic functions above. What is the equation of the axis of symmetry for each quadratic function? On my first example to the left, that line is going through x equals 4. On the right, it's going through the line x equals 3. And that vertex is on that axis of symmetry. So it's that x value. And we learned that p-value is the x value for a vertex. It's just the opposite. And in this case, yeah, it works. -4, the opposite would be +4. There's our line. In the second example, it's -3. The opposite is 3. So what is the equation of the axis of symmetry for any quadratic function written in vertex form? Whatever that p-value is, we have to do the opposite. Let's look at our max or our min values. Does each quadratic function have a maximum or a minimum value? So this one here, that's a min. It's the lowest part. And this one here is a max. It's the highest part. What is the maximum value for each? Here, that min value is happening at 2. And the example on the right, that max value is happening at -1. So when a quadratic function is written in the following form, that vertex form, which variable would tell you if there was a max or min value? Let's go back to our example. Here's the equation, and I have a min. Here's the equation for the second quadratic function, and I have a maximum. The variable that's going to tell you if you have a minimum or a maximum is the A value. And we're looking to see what sign is that A value. So here in this example, the A value is 1, and it's a positive value. And in our example 2, it's a negative. If we have a positive A value, we have a graph that faces up. And a way that I remember it is positive, happy, and oh, this is like a happy face. Now in graph 2, we have a negative. A negative reminds me of being sad, so sad face. So it's a graph that faces down. That highest point is a vertex. On a graph that faces up, the lowest point is a vertex. So the value that's telling you if it's a max or min is that A value, and whether it's positive or negative. If it's positive, you have a minimum point. If it's negative, you have a maximum point. And what variable would tell you if there would be a maximum or a minimum value? Sorry, this should go over here. And what variable would be the max or min value? Whatever that y value is. So here, graph 1, that's happening at the y value of 2. And in graph 2, the max is happening at the y value of -1. So whatever that q value is your max or your min. Determine A, P, and Q, the vertex, the axis of symmetry, if it opens up or down, and a maximum or minimum value for the following example. So let's first find out who's A, P, and Q. A is 2. P value, we'll write down the opposite, it's 4. And our Q value is -3. Now remember, I know this looks like a big 2, but it should be raised as a power. It should be that little 2. So actually this equation should look like this. All right, the vertex is our P value and our Q value, but we have to make sure that our P value is the opposite. The axis of symmetry goes through the X value of the vertex. We have a graph that is positive, so it opens up. And I always like to draw just a quick little graph that's opening up, and then I can visually see that, oh, the lowest point is that vertex. So the vertex is a min, and that is happening at our Q value, that Y value there. Next example, A, P, Q. Now just remember that 2 should be written as a power. A value is a -1, so here it is in front. P value, write the opposite, -5. Q value is -2. Vertex is happening at -5 and -2. We have an axis of symmetry going through that X value. We have a graph that is negative, so it opens down. Here's my quick picture to show it, which helps me see that that vertex is a max, and that max value is happening at whatever the Q value is, -2. All right, A, P, and Q. A value is -1.5. P value is a +9. Q value is an 8. The vertex is happening at 9 and 8. Axis of symmetry is happening at x equals 9. We have a negative graph, so it opens down, which means we have a maximum value at 8. And even for practice, we could have talked about the size of that quadratic function. So because that a value is 1.5, that value is greater than 1, and we don't care if it's positive or negative, we're just looking at the number, this graph is going to be narrow. And if I just back it up to those last examples, because this is good practice, here the a value is 2, that's greater than 1. This is also a narrow graph. And here it is. This guy here, a value is 1. This is normal. Remember, we don't care about the signs, we're just looking at the number. Okay. Oh. This example here would look like this. A value is a 1. P value, well, there's nothing else with that x, it's a 0. Q is a negative 2. So the vertex is happening at the point 0 and negative 2. The axis of symmetry is happening at x equals 0. I have a graph that opens up because the a value is positive. I have a minimum, the vertex is at the bottom, at negative 2. Now the a value is 1. This graph is normal. For practice number 3, questions 1 to 9.